Good day. This is Light Notes Part 3. We are going to skip along to the section right here, Part 3, where it says Reflection and Mirrors, and this corresponded to our Light Labs Part B. So reflection occurs when light bounces off an object, and that's what allows us to see an object, is because light's bounced off the object and come to our eyes. And later on we'll do a section on the eye and vision. We started with a plane mirror, and plane just means flat. And we get an upright image, and it will be reversed side to side. You did an activity where you learned that the angle of incidence equals the angle of reflection. The incoming ray that strikes the surface is an incident ray, and the ray that bounces off is called the reflective ray. Something you have to get used to is at 90 degrees to our mirror, we have something called the normal, and by convention we do all our measurements from the normal. You did an activity where you had to reflect light along a path. And if you're trying to predict how to place a magnet, you've got to split the angle in half. That will allow you to figure out the normal, and then at 90 degrees to normal, you would install your mirror. You did an activity where you folded mirrors together. At 90 degrees, you could see yourself the right way around. And at smaller angles than 90, and the smaller and smaller and smaller, you get more and more and more images. You get these repeated reflections, so you could see multiple U's. Once we hit B4, we move to curved mirrors. Convex are the ones that bulge outwards, and since they cause light to spread outwards, they are called a divergent mirror as well. And the image is always going to be right side up and smaller, and it has quite a few interesting uses, like in a sidecar mirror and in store mirrors and things like that, to see if people like me are shoplifting. Then we have concave mirrors, and of course they look like a cave. In this case, they cause the light to converge. That means meet at one point, called the focal point. And that at that point the light will crisscross, and if you're far enough away, then the image will have flipped over. So close up, a concave mirror will actually magnify you, and farther away it will flip over and you'll be inverted, and you get a description of those kind of things as well. As part of labs, you were told to know the difference between specular reflection, like what you get off a perfectly smooth lake or a mirror. You get what's called uniform reflection, where the rays come in and go out with no scattering. Of a bumpy surface, you get diffuse reflection because the light goes all over the place and you don't get a coherent image. So that takes us to refraction, and we'll deal with refraction in the next video.